all. I'm going to cover lesson 8.7 today. Never fear. In class next Thursday, we will go over any questions that you have, and we're also going to do in class the chapter test that's in the book so that you'll be ready for your chapter 8 test on Friday. So let's quickly do lesson 8.7. So I just copied the book so that we can look at it. I'll zoom in a little bit so we can read it better. So hold on. So this is applications of everything that we've learned so far. So here's a good application. Suppose an operator at the top of a lighthouse sights a sailboat on a line that makes a 2-degree angle with a horizontal line. The angle between the horizontal line and the line of sight is called the angle of depression. At the same time, a person in the boat must look 2 degrees above the horizontal line to see the tip of the lighthouse, and this is called the angle of elevation. So you might not have understood anything that I just said, so I'm going to draw the picture on the side and explain how to do this problem. So just move that right on over. So I'm going to take and I'm going to draw. Let me just switch it up to white so we can see it. So I'm going to draw the picture just using lines. So this is the distance that the boat is from the lighthouse. This is the lighthouse. And what we have is an angle of elevation and an angle of depression. So if the person on the sailboat, so we'll put the sailboat down here, is looking up to the top of the lighthouse. So this is the lighthouse. That person is looking from the sailboat to the top of the lighthouse. The angle of elevation, because we're going uphill, we're going from down low to uphill, it's said in the problem is 2%. Now the angle of depression is the line from the horizontal line, which is going to go across here, down to the sailboat. So the angle of depression is right here, and it's also going to be 2% because these lines are actually going to be parallel. And we learned these are alternate interior angles, so this is 2% as well, the angle of depression. So elevation goes up, depression goes down. Now they tell us that the lighthouse is 25, let me just check so I don't have to keep going back to the picture. The angle of the lighthouse is 25, I'm just trying to see what measurements, meters. So this is 25 meters. They want us to tell how far the boat is from the lighthouse. So we have tools for that. If we use this angle, this 2% right here, we could do opposite over adjacent. So we are going to use the tangent function. So we would say tangent of 2 degrees equals the opposite, which is 25, over the adjacent. So we would pop those numbers in our calculator. We would just put tangent of 2 in, and then we would divide by 25. So it would look like this. You can do it all in your calculator. If I cross multiply, and then I would divide by tangent of 2 degrees. If we would pop all that in our calculator, we would get x would equal approximately 716.3 meters. So it's about 700 meters from the lighthouse. Now I'm going to use the approximate signs here because that's what it is. It's approximately, so we don't necessarily put equals. I won't mark it wrong though. We could have also said this is 88 degrees right up here. And we could have used, we still would have used the tangent because we don't have the hypotenuse. So we could have said the tangent of 88 degrees. I just subtracted, if this is 90 degrees, I subtracted 2 and 88 from 180. And, whoops, it's approximately 88 degrees. Yeah, so that would be 90. So 90 and 90 is 180. So we would have gotten x, tangent of 88 is opposite over adjacent. So we cross multiply on that one and we would get the same thing. Approximately, this is a point. So it's going to be approximately 700 meters. The problems in 8-7 are all word problems. So I picture us going over these, but give it your best shot. Draw a picture before you do them. It makes it a lot better. So let's just run through some of the classroom exercises. The first one is a little bit strange. All they want to know is whether they're angles of elevation or depression. So let's just whip through that real quick. So what is the angle of elevation from X? Oh no, that's actually, it's the next one, it's like that. Okay, so we want to know what is the angle of elevation from X to A. So it's the angle of elevation it's from this horizontal line right here. So it would be 35 degrees. So that one is 30, hold on a second. It's 35 degrees, the angle of elevation, because it's going up from X to A. What is the angle of depression from A to X? Well, it's going down, and it's actually this right here. I'm going to erase this after I do this. This is the angle of depression. So it's going to be the same as the angle of elevation because these lines are parallel and these are alternate interior angles. The angle of depression goes from this horizontal line down to the line that has the elevation. So let me just erase that. It's really ugly. So it's going to be the same thing, 35 degrees. Now they want to know the angle of depression from A to Y. So we're going from A to Y. It's going down from this horizontal line. So it's going to be 23. And the angle of elevation is going to be right here. See how they're alternate interior? So they're going to be the same. So it's also going to be 23 degrees. And then it says, is the measure of the angle of elevation from Z to A greater or less than 35? So that would be this line right here. Angle of elevation is going to be greater than 35 degrees. All right, let's go on to the next one. Next page. Okay, now this is the one where you just have to tell whether they're angle of elevation or angle of depression. So let's try this one. So a person at H sights T. Well, look at that, it's going uphill. So it's going to be the angle of elevation. These are easy. A person at H, where's H, sights G. So it's going down. So it's going to be the angle of depression. T sights H. Well, it's going down. So it's going to be the angle of depression. And then G sights H. So it's going up, so it's the angle of elevation. You probably hope the whole test is full of those kind of problems. All right, now the next two get a little bit trickier, so let's try those. I'm going to pull over to the side to do these again. It says a driveway has a 15% grade. It's not saying that it's 15 degrees, it's a 15% grade. What is the angle of elevation of the driveway? And if the driveway is 12 meters long, how much does it rise? So pulling over to the side, take notes of that. This is in your book. It's the classroom exercises. So I'm going to pull over here, switch it up to some white so it's not too ugly, and try this problem. So it's telling us that the driveway has a grade of 15%. So I'm going to, whoops, so much for the white. The grade is 15%. I'm going to make it a little bit more so that I can write in here. 15% isn't very much. So it's telling us that the grade of the driveway is 15%. Now that's a little tricky. So it's 15%. 15% is 15 over 100. This is going to be, it's also, when they tell you the grade is 15%, it's the same thing as your rise over run. So your rise over run is going to be 15 over 100. I mean, of course we can reduce that, but let's just leave it like that for now. So our rise is going to be 15 and our run is going to be 100. Now we can figure out what this angle of elevation is. So we have tangent again because we don't have the hypotenuse. So we would say the tangent of, we can just call it theta, equals rise over run, which is 100. So we just use our calculator. So we would do the inverse tangent of 15 over 100. You pop that into your calculator and you're going to get that it is, the angle is approximately, I always forget to do this approximately thing, 18.53. So that's the angle of elevation. So it's going to be 8.53 degrees. Now, once you get that, what do they want us to say? The driveway is 12 meters long. So we're going to ditch these numbers. That was just to help us find the angle because it gave us the percent of the grade. Now it's telling us the driveway is 12 meters long and we need to find how much it rises. So we need to find this value x. So let's just change our colors here a little bit. So we know what the angle is, and we have, again, it's going to be tangent because we don't have the hypotenuse. So we would say tangent of 8.53 equals opposite over adjacent. So on our calculator, we would say tangent of 8.53 times 12 equals x. And when we put that in our calculator, we would get x equals approximately, again, 1.8 meters. So a little tricky, just be careful. Whenever they give you the percentage, you need to use it as your rise over run to first find the angle. All right, last problem, and I expect we'll have to be doing some of these in class on Thursday. So a toboggan travels from point A to point B, which I cut off at the bottom. Because of the steepness of the hill varies, the angle of depression from A to B is only an approximate measure of the hill's steepness. We can, however, think of the angle of depression as represented by the angle of steepness. All right, the average steepness. So I'm going to again go, well, let's just look at this picture real quick. The angle of depression, now this can get confusing. So the angle of depression, I'm just going to put this dotted line. Remember, it's the angle from this top line, which would be right here. You can see it's going to be approximate because it depends where we hit it. If we do the angle here, the line's kind of wavy. That's why it's more approximate. This is, why is your answer approximate? Well, this line is kind of wavy. All right, this angle right here is going to be the same as this angle. So this is your angle of elevation and your angle of depression are the same thing. So I'm going to pull over again and redraw this picture. Let's erase all that. So let's redraw it. So we have, this is the kind of the top of the hill, and this is the base, the distance, and here is, I'm just going to draw a straight line. Now since it's wavy, it's going to be more approximate. All right, so it's saying that if the toboggan travels 130 meters from A to B, so this is going to be 130 because this is A and this is B. The vertical descent is 50. What is the angle of depression, which is this angle right here? Remember how we talked about the angle of depression is right there? So these are going to be the same. So I'm going to use this angle right here. We'll just call it theta. And they want to know the angle of depression, which is this angle too. So we would do, we have opposite, which is sine over hypotenuse. So we'd say sine of theta equals 50 over 130. So we would say theta equals the inverse sine. You can reduce it. I actually did this time because it's so simple. 5 over 13. You pop that guy in your calculator. and you get 22.62. And that would be degrees. And then with that information, we could easily find out how far away they went from the starting point. So we could do that. We could say, they don't ask us to do that, but we could just say the tangent of 22.62 is opposite over adjacent, and then you could solve for that if you wanted to know what x was. All right, so that's about it. All the problems are a little different. Just make sure you get the angle of depression, which is the same as the angle of elevation. The angle of depression always comes from this horizontal line across the top. All right, so that is it for lesson 8-7. Also, please, if you have any questions, I have the help board set up, or you can email me and I'll try to send everyone the answers to anyone's questions. All right.